Okay, one thing we need to do with our right-angled triangle when we're talking about trigonometry, or some other things too, is name our sides. And if you remember Pythagoras, the side opposite the biggest angle, the longest side, is called the hypotenuse. So we can always name that one, we can always identify it and then name it really easily. We can see where the right angle is because it's often denoted by the square. We can see where the right angle is, and we can also see which one of our sides is the longest. In all of these triangles, we can see which side is the longest. That one's called the hypotenuse, or hype for short, shortest of all, h. So there's hypotenuse, hype or h. The side opposite, the longest side, it's opposite the biggest angle. It's called the hypotenuse of a right angle triangle. And let's put h in all of those others. I've made it really easy because I've put these in blue. Okay, so that leaves two shorter sides, and we need to distinguish between those two shorter sides. And so, given an angle, we're going to name these sides where they are relative to the angle that we know in the right angle triangle. The second angle, that is, because we already know one of the angles in the right angle triangle, and that's the right angle. So in all three triangles, we're given another angle that's noted. So one of these sides is next to the angle, and the other side is opposite to the angle. And if we look to see what makes up this angle, I've got two sides. One of them is the hypotenuse, and the other is a shorter side. And that shorter side I'm going to call adjacent to the angle, or adj, or shortest of all, A. And the other side that's not adjacent to the angle, so it doesn't touch the angle at all, is called the opposite, or op, and shortest of all, just O. So in these other two, why don't you draw a sketch of those two and see if you can put in opposite and adjacent. Okay, there's my angle. It's made up of the hypotenuse and the adjacent side. So this one's A, or adj, and so the other one is opposite. In this triangle, there's my hypotenuse, the other side making up this angle is adjacent, so the other one is opposite. There we go. Hypotenuse, opposite, and adjacent. Okay, here's how trigonometry works, really, or why it works. Let's have a look at this triangle. And this is a right angle triangle. The hypotenuse is 10. The opposite side, the side opposite my angle alpha, which I've decided is going to be 36.87 to 2 decimal places, and my adjacent side 8 is adjacent to this angle. There's my triangle. And what I'm going to do is enlarge it. First of all, by a scale factor of 2. So this side, which was 6, is now 12, this was 10, it's now 20, and this was 8, it's now 16. And what I want you to see is that because those two triangles are similar, because the angles are all the same in this triangle compared with the one which is half the size, then the ratio of this side compared to that one, the opposite divided by the hypotenuse, is 6 over 10. And when we double the size, it's still 6 out of 10. 12 out of 20 cancels down to 6 over 10. 8, so that's 6 divided by 10. If we look at the adjacent divided by hypotenuse, this ratio of the adjacent side to the angle divided by the hypotenuse, that's 8/10, or 0.8, or 4/5. And 16 divided by 20 is also 0.8, or 4/5. And the final one of our three ratios that we're looking at in basic trigonometry is the opposite side divided by the adjacent. And in this case, it's 12 divided by 16, which cancels down to 3/4. And in the smaller case, 6 divided by 8, which also cancels down to 3/4. And we can choose any enlargement factor. This is from the basic one of 6, 8, 10. This is a scale factor of 1.5. So my opposite side goes from 6 to 9. 6 times 1.5 is 9. But look what happens to the ratios. Opposite divided by hypotenuse is still 9 over 15, which is 3/5. 9 over 12, which was the opposite over adjacent, that's still 3/4. And 12 over 15, which was the middle ratio, the adjacent divided by hypotenuse, that's still 4/5. And we can see that whatever our enlargement factor is, those ratios remain constant. And that's why trigonometry works, essentially. And it's not just a case of having this particular triangle. If I choose different sides, so if I choose, let's say, 5 and 12, then we can see that the opposite side would be adjacent side 12, opposite side 5, hypotenuse 13. 5, 12, 13 triangle. If we halve the size, then I've still got 2.5 divided by 6.5, which would be the same as 5 divided by 13. I've still got 6 divided by 6.5, which is the same as 12 over 13. And I've still got 2.5 divided by 6, which would be the same as 5 divided by 12, and so on. And if we can see this one, I've multiplied by 1.4. The scale factor compared to the 5, 12, 13 is the scale factor of 1.4. And we would still get exactly the same ratios when we compare sides which are equivalently relative to what they were before. When their corresponding sides, corresponding ratios stay the same. And that's it. So now we've seen how to name the sides of our right angled triangle in terms of hypotenuse, opposite and adjacent. And we've seen a bit of an animation about the sizes of the triangles getting bigger. So I've kept with my 3, 4, 5 triangle. This one is 2 times 3, 2 times 4, 2 times 5. This one is 0.9 times 3, 0.9 times 4, 0.9 times 5. So the ratios, I wanted to use these, just two random triangles, but they've both got the same angle, they're both right angles, so this third angle, the middle sized angle of 53.13, that's the same in both cases as well. So this one is an enlargement of that one. One is, they're both similar triangles. And we can see that if we look at the ratios of opposite compared to hypotenuse, in the first triangle, the opposite compared to hypotenuse is equal to 2.7 divided by 4.5. And that is equal to 3/5. In the bigger triangle, in the larger of the two, the opposite over hypotenuse is equal to 6 over 10, and that's equal to 3/5. They're the same. This ratio compared to that ratio, for these two different sized triangles, because the angle is the same, these two ratios are the same. If we look at the adjacent versus hypotenuse, so adjacent divided by hypotenuse, in the smaller triangle, it's 3.6 divided by 4.5, and that is equal to 4 over 5. And in the larger triangle, the adjacent side 8 divided by the hypotenuse 10 is 8/10, and that cancels down the same equivalently to 4/5. So that this 4/5, this ratio of adjacent divided by hypotenuse is the same as in the smaller triangle because the angle is the same. And finally, the adjacent side divided by, the opposite side divided by the adjacent. I have 2.7 in my smaller divided by 3.6, and that's equal to 3/4. And in my larger triangle, opposite divided by adjacent is 6 over 8, and again that easily cancels down to 3/4. So we can see that these ratios for the same angled right angled triangles, one is an enlargement of the other, they're both similar. The ratios of one side divided by the other, as long as they are in respect to each other, they're relative to each other, the opposite to the angle divided by the hypotenuse, the opposite divided by the hypotenuse is 3/5 in both cases. And we call this ratio the sine of the angle. And the angle in this case is called alpha, 36.87, roughly to 2 decimal places. And the adjacent versus hypotenuse, divided by hypotenuse, that's called the cosine of alpha, shortened to cos. And the opposite divided by the adjacent we refer to as the tangent ratio. Tangent of the angle is equal to the opposite over adjacent. So in the next video, we're going to use SOH, CAH and TOA. And what they refer to is the sine of an angle is opposite over hypotenuse. Sine opposite hypotenuse. The CAH is cosine of the angle is equal to the adjacent over hypotenuse. Cosine, adjacent, hypotenuse. And the TOA is the tan of the angle opposite, adjacent. T for tan, O opposite, A adjacent. So in all these three cases, the first one tells you what the first letter of the trigonometry is, whether it's the sine, cos or tan. So in this case, S is sine. And the second two tell you which sides that we divide by each other. And O is the one on top, and then we divide O by H. Opposite divided by hypotenuse is the sine. The cosine, C for cosine, is adjacent divided by hypotenuse, and T for tan, O for opposite, A for adjacent. Tangent of the angle is equal to opposite over adjacent, as we've done there. So those are the names of our ratios, and in the next video we'll see how to use those to calculate missing sides and missing angles. Thanks for watching. Hope that was a good intro to trig for you. For many of you, probably it just refreshed a few things that you already thought you knew or that you already knew. Thanks for watching. Bye for now.